All right, let's write a piecewise function for these two, numbers 18 and 19. I'm going to start with getting the f of x equals big bracket ready. And notice we have two pieces and they're both linear, so we're going to be plugging into the m x minus x1 plus y1 format. So get me an m for piece number 1 and get me any x1, y1, and then get me an m and get me any x1, y1 for piece 2. So pause the video and try that. So I'm showing this as like down 2 over 1. And then I'm going to use this dot here. No, let's use this dot here of 0, 1. No, let's not do that. Let's use this one. 1, 2, 3, 1, 2, 3, 4, 5. So 3, negative 5 is the point I'll use. And on the other one over here, let's do a slope of up 1 over 1, 2, 3, 4. Do you see that 1/4 slope? And let's use a dot of 1, 2, 3, 4, negative 1. So now that I have those two pieces, I'm ready to go plug into this function. I'm going to say m x minus x1 plus y1 and m x minus x1 plus y1. Now we're going to put our domain. The domain of this one goes from 0 to 3, and this one goes from 4 to 8. And they're closed dots. So we're going to say from 0 to 3 inclusive, and from 4 to 8 inclusive because of those closed dots. How'd you do? Pause the video, try the second one on your own. Like for real, pause it. Okay, first one, I'm getting a slope of up 1, 2, 3, 4 over 1. x1, y1, let's do 1, negative 1. Second piece, it's a negative slope, it's going down. Oh, what is that? Down like a half and over 1, 2, 3.5. This one is super sucky. Sorry, guys. Let's see. Down half over 1, 2, 3.5. That is just a terrible one. Sorry, guys. And so let's go plug these into, oh, you need an x1, y1. Let's do this one here because it's definitely way easier. 1, 2, 3, 4, 5, 6, 7, comma, 0.5. And so here we go. F of x equals, let's do slope of 4, x minus 1, minus 1. Slope of 0.5 over 3.5, x minus 7, plus 0.5. And then my domain for this is going to go from 1 to 3, and then from 1, 2, 3.5 to 4, 5, 6, 7. Ooh, that second one was not fun. Sorry about that. All right, we did number 20 in class. It wants you to put the parent function on each of these graphs first. So go ahead and take a minute. And put the parent function on each of these graphs first. So starting at the origin, going out one, up one. And then now making these shifts. So this is a left 3, down 5. So 1, 2, 3, 1, 2, 3, 4, 5. And it is a reflection and it is a stretch of 2. And so the function for this, g of x equals negative 2 because of the upside down, x minus a negative 3 squared minus 5. So this one over here is a shift right 1 and then up 4. So right 1, up 1, 2, 3, 4. There's my new vertex. And it's just going to stretch vertically by 3, no reflection. So out 1, up 3, and out 1, up 3. And there's my new parabola. So if my vertex is at out 1, So out 1, up 4, there's my vertex, stretch of 3. We're going to write 3x minus 1 squared plus 4 as our function. Last, shift up 3 and left 6. 1, 2, 3, 4, 5, 6. Up 1, 2, 3. It says to reflect it and stretch a half. So out 1, down a half. Out 2 is normally down 4. We're going to go out 2, down 2. And then connect it. We know it's going to be negative 1/2 x minus a negative 6 and up 3. Don't forget the squared. Okay, and obviously label and scale all your graphs anytime you're graphing. How'd you do?